Okay, welcome back. This is the part 2 of the Unit 3 review. We got cut off on time for the last video. So this question says, which expression is equivalent to 7 times 7 times 7 times 7 times 7 times 7 times 7? So we're going to rewrite this as an exponent. The base is going to be 7, and then we're just going to count and see how many we have. 1, 2, 3, 4, 5, 6, 7. So we have 7 raised to the 7th power. What is the base in this exponential term? So I like to think of base like in terms of cheerleading. You have like a base and a flyer when you do a stunt group. The base is always the bottom person holding up the flyer. And I think of exponents the same way. So in this case, I have -3 on the bottom and it's holding up 5. So -3 is the base and 5 is the exponent or the flyer. So in this case, -3 is the base. We want to simplify. So y'all know I've been talking about calculators so much. You could do the math and write this out and do multiply by 3 5 times. Or you could go to your calculator and just type it in. So I'm going to go to the calculator and type both of these in. For the first one, I had 3 raised to the 5th. So I'm going to do 3. And then I'm going to raise it. See, this one says that you're raising it to the 2nd power, but I want to be able to type in any power. So I'm going to hit this one, and then I can type in a 5. And hit enter, and that equals 243. And if you weren't confident about which button to use, you could also go in and type 3 times 3 times 3 times 3 times 3 5 times, and it would tell you 243 as well. And then the next one on that page was 13 raised to the 0 power. And 13 raised to the 0 power is 1. And here's a helpful hint. Anything, literally anything, raised to the 0 power always equals 1. So that's kind of always a free question. If it's anything raised to the 0 power, you know your answer is 1. So back to our smart notebook. This one equaled 243 and that one equaled 1. Okay, so we got some more simplifying here. Now, I'm going to show you how you can write it out, and then I'll also show you how you can type it in the calculator. In this first part, we have 2 to the 8th power, so we could write it out as 8 2s. 1, 2, 3, 4, 5, 6, 7, 8 times, and then in the second part, we have 2 to the 5th power, so we could write it out 5 times. 1, 2, 3, 4, 5. So you could write it out all like that, or you could write it in exponent form, which means you just need to see how many you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you could write it as 2 to the 13th, or you can multiply that in your calculator. I'm pretty sure in this case, it just wants you to write it as 2 to the 13th power. And there is a shortcut. If you don't want to write out all of the 2's, you could just take your exponents and you could add them, because 8 plus 5 equals 13. But sometimes I don't forget my properties, so sometimes I like to write it out. Okay, and then for the next one, we have 9 to the -4th. Well, let me just tell you, negative exponents don't make sense. Because what exponents tell us is they tell us how many times we're going to do it. So like an 8 makes sense. You can do something 8 times. A 5 makes sense. You can do something 5 times. You can't do something -4 times. It just doesn't make any sense. We can't write it down like we can't, I don't know, go up to bat -4 times. You just can't do something negative times. So if we ever have a negative exponent, we always need to make it a positive exponent. And the way that we do that is we move it. So every number can be written, or this number can be written as a fraction by putting it over 1. And if we want to change that to make it a positive exponent, we have to take this base and exponent and we have to move it. Since it's on the top, we're going to move it down to the bottom. We're just going to flip this fraction, and that makes the exponent positive. If it was on the bottom and it was negative, you would move it up to the top. But whenever you see a negative exponent, you've got to move it, because otherwise it doesn't make sense. You got to turn it into a positive exponent. So in this case, you could either, depending on how the multiple choice answers are, you could either leave your answer like this, or they might multiply it out. They might do 9 to the 4th power. So 9 times 9 times 9 times 9, which you could just type in your calculator as 9 raised to the 4th power. And it might be written as 1 over 6561, or it could even be written as a decimal. I don't know what it's going to look like, but there's lots of different ways you could write that answer. You just have to know that when you have a negative exponent, that doesn't make any sense. You've got to turn it into a positive exponent by moving it, either up or down. Okay. For this one, we want to simplify. Now, this is a division symbol. I don't like using that division symbol. I like to use the fraction bar. Oops, I don't know what I just wrote there. That was supposed to be a 5. So I'm going to rewrite this as 5 to the 14th over 5 to the 3rd. That's the same thing. This division line is the same thing as the division symbol. It just organizes better for me when it's like that. So what you could do, if you don't remember your properties, you could write out 5 14 times on the top. I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because that power tells you how many times you're going to multiply it. And just pretend like there's dots in between all of those for multiplication. I don't have time to fill them all in. And then I'm going to do the same thing on the bottom. 5 to the 3rd power means that I have 3 of those 5s. And then, because it's a nice fraction and we're dividing, those would cancel, those would cancel, and those would cancel. And then I could just count and see how many I'm left with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm left with 11 5s, or 5 to the 11th power. So that's the long way to do it, but that way always works. If you remember your shortcut says that when you divide with the same base, you can keep the base the same and subtract the exponents. So you could have just written down the same base, which is 5, and then you could have subtracted your exponents, 14 minus 3, and that would give you 11. So either way you do it, you should get 5 to the 11th power. My last cell phone had 8 gigabytes of storage. That's supposed to say 7. I changed this number. This is the same as 7 times 10 to the 9th bytes of storage. Write 7 times 10 to the 9th in standard form. All right, right now this is in scientific notation. And scientific notation is just a fancy way to write numbers that are really, really, really big or really, really, really small without writing it out forever. So it's just a shorthand way of writing huge numbers. But if we want to convert it, this times 10 to whatever power tells us how many times we want to move our decimal. So right now in 7, you don't see a decimal. And if you don't see it, it's always hiding at the end. So what we're going to do is we're going to take and we're going to move that decimal 9 places. And I usually just kind of make little humps. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the new decimal is going to go. And in every one of those blanks, I have to add in a 0 as a placeholder. So if we rewrote this in standard form, how many zeros is that? 9 zeros? Whew, and then you put a comma every 3. So there we go. That is rewritten in standard form. The sun is 82,700,000 miles away from the Earth. Express this distance using scientific notation. Okay, so now we're going in reverse. We're going to take this giant number and we're going to write it in scientific notation, which means it has to be times 10 to some exponent, which we're going to figure out in just a second. So what we want to do is we want to take the number, not including the zeros. All right, so I'm going to look right here. I know that I'm going to have those numbers included in my scientific notation out front here. But what I'm going to do is I'm going to start where the decimal is. And if we don't see a decimal, it's always hanging out here on the back. So let me rewrite this. Since we didn't see a decimal place, it's hanging out here. I want to move that decimal all the way up until it's behind the very first number. So I'm going to count how many times I have to move it to make that happen. 1, 2, 3, 4, 5, 6, 7. Okay, and now I want to rewrite those first three numbers with that decimal after the first number. And since I moved it 7 times, that's going to be my exponent. So that one in scientific notation would be 8.27 times 10 to the 7th power. Okay, subtract. So in this one, it says to show your work thoroughly. So we would have to get a common denominator. I know in most of this video, I've been telling you to go to Desmos and type it in. And I would 100% still go to Desmos and type it in so I knew what my answer was supposed to be. But then we got to go back and show our work too. So I'm going to get the answer first. So I'm going to come over here and I'm going to type in 4 over 8 minus another fraction of 5 over 6. And I'm going to get my answer, and it tells me negative 0.33, but I want that answer as a fraction as well. All right, so I know that my answer is going to be negative 1/3. I like to use my calculator first, just so I know what the answer is supposed to be, so that when I show my work, I make sure that my work is actually giving me that answer. So now that I know what the answer is, I'm going to go back and show some of my work. So I know that it's going to equal negative 1/3. Now I'm going to have to go and I'm going to have to get common denominators to try to show all of my work. So if I look at my denominators, you can try to find the least common denominator, or you can multiply your fractions by the opposite denominator. And that's usually what I do. So if I look at my problem, one of my denominators or bottom numbers is 8, and the other one is 6. So what I'm going to do is I'm going to take my first fraction, 4 over 8, and I'm going to multiply that fraction by 6, which is the opposite denominator. And then I'm going to take my second fraction, which was 5 over 6, and I'm going to multiply it by 8, which was the other denominator, or the opposite. So you can do all of this work in your calculator. 4 over 8 times 6. That gives me 3. And then 5 over 6 times 8. I'm typing this in a calculator. Sorry, I'm not showing you, but hang on just a second. Okay, I didn't really like the way that I was showing you. I was typing this in my calculator, but it's going to be a lot easier since we're trying to get common denominators if I just show you just multiplying. So 4 times 6 is 24. So that's going to be 20. Oh, geez, what did I just write? It's going to be 24. And whatever you multiply to the top, you have to multiply to the bottom. And 8 times 6 is 48. I should have just written that on top and bottom. All right, so that's how I got that one. And then I'm going to do the same thing over here. 5 times 8 is 40. 6 times 8 is 48. And now that I have common denominators, meaning the bottom is the same, I can just write down that same denominator, and then I can take my top two numbers and I can subtract them. So my top two numbers say 24 minus 40, and 24 minus 40 is negative 16. So we got common denominators, we subtracted, and now we ended up with this. But it says simplify your answer if possible. Negative 16 over 48 is not in simplest form. The cool thing though is that you can get it in simplest form simply by typing it in your calculator. So as you can see, when you type that in your calculator, you do get the negative 1/3, which is what we knew the answer had to be all along. Just wrote out our steps here. Get a common denominator, keep the denominator the same, and subtract the numerator, and then simplify the fraction. Let's do our last question together. So for this one, it wants us to take 4 to the 8th times 4 to the negative 2. Well, when we multiply with the same base, we can simply add the exponents. So 8 plus negative 2 is 6. So our answer is 4 to the 6th. But that doesn't work on this next example because one base is an 8 and the other base is a negative 2. You have to have the same bases in order to take that shortcut. All right, Make sure you go complete the 2-question quiz on Schoolology and then take the test retake.